What's going on, you guys, and welcome back to the Orlando Science Center. I'm Marquise Meda, joined by Zach once again. And today, Zach, as the kids are saying, we are getting lit.
Yeah, we're gonna make some lights definitely flash and blink. We're gonna talk a little bit about circuitry and basically how all of the lights around your house and in spaceships out in outer space are powered. There's basically three different components, other than all of the miles and miles of wires. That's going to be your power sources, which are batteries, our resistors right over here, and our results, which are going to be our LED lights. And the first, most basic of circuits is this open circuit right here, where you just have your battery, your power source, and it runs all the way through. This is basically transferring that electric current through those electrons, through the LED light, and of course, making that light emit.
Cool. All right, that's pretty easy.
Pretty easy indeed. We're gonna make it slightly more complicated. Still going to keep it a nice circle, but this is going to be adding our resistor. And this is pretty straightforward. It's not turned on even though it's all connected because this button is blocking that electric path unless I push down on it, and then it makes our light up. And then you can do like a little Morse code or like a cool little rave party with it.
All right, jingle bells, jingle bells. There
Perfect for July. But a lot of the times your light switch might turn on multiple lights at the same time or have multiple purposes. That is called a parallel circuit, and it is a little bit more complicated. So I'm going to go ahead and run that right now. It will take me a second to set up.
So as you're running this, what exactly do the clips do?
So the clips are all soldered together, so they're connecting the electricity. They're basically wires, and the clips just help transfer that electric current as well. So these are basically copper wires. They're able to really effectively transfer that electricity, which is super, super helpful.
Okay.
And then my last clip right here. So you can kind of see we've turned our circle into like a figure 8. We basically have two different circles, and we're going to be able to power on both of these.
Rotate it this way.
Let's rotate
Let's
it
go the
around.
long way.
There we go. And so once again, power is going from our battery into our two light emitting diodes, our LEDs, but it is being blocked by our button right here. So once you click that on, and I press this button, you just see both of our lights turn on at the exact same time. So our switch right here is doing exactly that. And this works for all of our resistors, so we could take off this button and change it over here to our very classic light switch and turn on our lights.
Awesome. So I guess the question that I would have, or many viewers would have, is it the same amount of energy going to both different light sources, or is it dispersed? Is it multiplied? Is it divided?
Yeah, so it's not being multiplied. It is actually being divided. So the reason that we're using LEDs for this is because basically once they reach their amount of charge that they need, they're going to emit their maximum amount of light. Mm-hmm. So if we give them too much energy, which 2 AA batteries definitely is too much for these,
it's a lot, yeah.
They'll still emit the same amount of light as if it's cut in half, which is happening right now as we're using 2 AA batteries for each of them. So that power is being split in half. So that's a thing that you need to worry about when you're doing a parallel circuit, is the amount of energy reaching each result.
Cool. Let's see if we can swap this out. Let's obviously turn off the electricity first.
Of course. We'll go ahead and do like the classic Frankenstein "It's Alive" lever. And so you can see you kind of pull it up and it stops that. The electricity is actually physically running through this. And then when you let each side connect, it turns on those LEDs once again.
Okay, so it's a closed circuit versus an open circuit.
Exactly. And then the last resistor here is one of my favorites. This one is a swivel resistor, and basically it can actually help dim the LEDs. So we can actually play around with even more the amount of electricity they're receiving and dim them up and down.
Okay, I see you out here setting the mood.
Yeah, exactly, yeah.
Well, throughout the month of July, we do have Astronomy Month going on here at the Orlando Science Center. We've got so many different experiments and activities, not just circuits, but so many different vast experiments in which we can look at the stars and gaze a little bit. But I hope to see you guys all here at the Orlando Science Center.